Arithmetic sequence is a sequence where terms are obtained by adding a constant value called the common difference, which is denoted by the lowercase letter d. Now let's go on to the examples. First example, 1, 4, 7, 10, and so on is an example of arithmetic sequence because it has a common difference, which is 3. And how did we get 3? We just subtract the second term with the first term. 4 minus 1 is equal to 3. And you can also check that one with other terms. Just like subtract the third term with the second term. 7 minus 4 is equal to 3, and so on and so forth. When you subtract those terms, it should have a common number. And that common number is the common difference. Now let's go on to the second example. 15, 11, 7, 3 is also an example of arithmetic sequence because it has a common difference, which is -4. Again, how did we get the common difference? We just subtract the second term with the first term. 11 minus 15 is -4. Okay, let's continue. If we have this sequence again, 1, 4, 7, 10, and so on, and I'm going to ask you, what is the 87th term? To answer that one, we can simply do basic addition. So we can continue the sequence by adding the constant value, which is the common difference 3. So the next term is 13, next is 16, 19, and so on and so forth. By doing that process, it could consume a lot of time. So here, I'm going to introduce to you the formula in finding the nth term of an arithmetic sequence. And that is a sub n is equal to the sum of a sub 1 and the product of the quantity n minus 1 and d, where a sub n is the nth term and a sub 1 is the first term, n is the number of terms, and d is the common difference. Now let's solve that one using the formula. But first, we need to write the given or the knowns. So, first term or a sub 1 is 1 because that is the first term in the sequence. N is 87 because that is the number of terms that is being asked. And D is 3 because the common difference is solved this way. 4 minus 1 is 3, 7 minus 4 is 3, 10 minus 7 is 3. Now let's write the formula and substitute the following given. After substitution, we need to operate the following operations by applying PEMDAS. So first, we operate the operation inside the parentheses. 87 minus 1 is 86. Next, copy everything that is left. Next, you need to multiply 86 and 3, and that gives you 258. And then copy what is left. Next, 1 plus 258 is 259. And that is the 87th term. How about if you are asked to solve for the common difference, wherein the nth term is given? So example, the first term of an arithmetic sequence is 4, and the nth term is 31. What is the common difference? Now, to solve that one, first we write the given or the knowns. Nth term is 31. First term is 4. N is 10, while the common difference is unknown. To solve that one, we still use the same formula, and we substitute the following given. And again, by using PEMDAS, we first solve the values inside the parentheses. 10 minus 1 is 9. Times D, that will be 9D. Then copy everything that is left. Next, to separate those numbers with variables and without variables, we apply addition property of equality to cancel out 4 on the right side. So 4, we put negative 4 here on the right side, and what is written on the right side should also be written on the other side. Now we can cancel 4. What is left on the right side is 9D, and while on the left side we have 27. Now, to cancel out 9, we apply MPE, which is multiplication property of equality. We multiply this one with 1 over 9. What is written on the right side should also be written on the left side. Next, we can cancel out 9 now. What is left on the right side is D. And while on the left side, we have 3. So the common difference is 3. If you're asked to solve for the number of terms or the value of n, we can apply the same process. Example, the first term of an arithmetic sequence is 4. The nth term is 31. And the common difference is 3. What is the value of n? To solve that one, first, we need to write the given or the knowns. Nth term is 31. First term is 4. Common difference is 3. And the value of n is still unknown. To solve that one, we still use the same formula. Substitute the following given. Next, let's try to distribute 3 to n and to negative 1. Next, to separate those numbers with variables and to those without variables, we apply addition property of equality. So to cancel out 4 here, we put negative 4 here. And to cancel out negative 3 on the right side, we put positive 3 there. Next, what is written on the right side should also be written on the other side. And now we can cancel 4 and negative 3. What is left on the right side is 3n. While on the left side, we have 31 plus 3 is 34 minus 4, and that is 30. So, to cancel out 3 here on the right side, we apply MPE, which is multiplication property of equality. We multiply that one with 1/3. What is written on the other side should also be written on the other side. Now we can cancel the 3. What is left on the right side is already n, and on the left side we have 10. So the number of values or terms is 10. Next, let's try to know what is arithmetic mean or arithmetic means. Is or are terms between any two non-consecutive terms of an arithmetic sequence. When we say non-consecutive terms, pasabot ana, wala nagsunod. For example, 1, 7, 4, 10, 7, 13, 1, 10, 1, 13 are non-consecutive terms. Kaya wala silang gasunod. Now, to know what is arithmetic means, let's have this example. 1, 4, 7, 10, 13. The arithmetic means between 1 and 13 are 4, 7, and 10. So, the terms between 1 and 13 are called arithmetic means. The arithmetic mean between 1 and 7 is 4, while the arithmetic mean between 1 and 10 is 4 and 7. While the arithmetic mean between 4 and 13 is 7 and 10. While the arithmetic mean between 7 and 13 is 10. In solving for arithmetic means, we need to solve first for the common difference. Example, insert 3 terms between 2 and 34. In figures, that is 2 and then 3 blanks, which represents the 3 arithmetic means, and then 34 is the last term. So, to solve this one, I'll be introducing to you 2 ways. The first way is using the formula, while the second way is by shortcut method. So the first method is using the formula. So write the formula first. Next, substitute the following given. So a sub n is the last term, which is 34. A sub 1 is the first term, so that is 2. And then the value of n is 5 because there are 5 terms. 1, 2, 3, 4, 5. Next, and d will be unknown. Next, we operate the following operations using PEMDAS. So first, we operate those numbers inside the parentheses. 5 minus 1 is 4 times d, that will be 4d. Next, to separate those numbers with variables and those without variables, we apply APE. So, to cancel out 2, we write -2 on the right side. What is written on the other side should also be written on the other side. So that's why we write -2 here. Next, we can now cancel out 2 and bring down 4d. And on the left side, we have -2 plus 34. The result is 32. Now, to cancel out 4, we apply MPE, which is multiplication property of equality. And we multiply that one with 1/4. What is written on the other side should also be written on the other side. So we write 1/4 also here. Now, on the right side, we can cancel 4 and what is left on the right side is already D. How about on the left side? 1/4 times 32, and that is 8. So the common difference is 8. Now, we can add the common difference to our first term. So, 2 plus 8 is 10. And that will be the second term. 10 plus 8 is 18. That will be the third term. While 18 plus 8 is equal to 26. And that is the fourth term. So, the three terms are 10, 18, and 26. So, by using the shortcut method, we only have 3 steps. The first step is subtract the nth term with the first term. So, here, our nth term is 34, while our first term is 2. So, 34 minus 2 is 32. Second step, divide the result of step 1 by n minus 1. So, the result was 32. We divided 1 with n minus 1. And the value of n is 5 because there are 5 terms. So, 5 minus 1 is 4. 32 divided by 4 is 8. Now, 8 is the common difference. So, we proceed to step 3. And that is, add the result to A1 to get the next terms. The first term is 2. So, we add 8. And that is 10. While the next one will be 10 plus 8 is 18. And 18 plus 8 is 26. So, the three terms between 2 and 34 are 10, 18, and 26. Arithmetic series. It is the sum of terms of an arithmetic sequence. So, to solve that one, you can choose either of the two formulas. You can have this one or this one. So, the legend for the formulas are the following. Sn is the sum of terms, A sub 1 is the first term, n is the number of terms, and d is still the common difference. Now let's proceed to solving for the sum of terms or solving for the arithmetic series. Example, find the sum of the first 10 terms of the arithmetic sequence 5, 9, 13, 17, and so on. So, to solve this one, we will apply the formula. So, first, we will identify the given. The first term is 5. The number of terms is 10, while the common difference is 4. And for the sum of terms is still unknown. The sum of 10 terms is still unknown. So, again, write the formula. Next, we will substitute the given to our formula. So, n is already 10. The first term is 5. And n again is 10. And the common difference is 4. Next, using PEMDAS, first we will solve the innermost equation. So here, we have 2 times 5 is 10. And 10 minus 1 is 9. 9 times 4 is 36. Next, we copy 10 and also 2. Again, still we have a parenthesis. Solve 10 plus 36 and that is 46. And copy 10 again and 2. 10 times 46 is 460. Copy 2 again. 460 divided by 2, that is 230. So the sum of the 10 terms is 230. So that's it, class. Thank you for watching. I hope you've learned something from this video. To be more updated for my future videos, please subscribe in my channel, push the notification bell, and hit the like button. This is Sir Chan, signing off.